We'll be spending most of the rest of this semester looking at minerals and trying to identify them with their different properties. But minerals are strongly tied to our economy as well and our daily lives. So this learning video is going to concentrate on that topic, how minerals are related to economics. Here are the learning outcomes for Unit 5B. Go ahead and pause the video and write these down. Typically, when I teach this course face-to-face, we have a lab where we look at a variety of materials and we match them up with the minerals from which they're derived, and we talk about different minerals and their uses. We aren't going to be doing this in our online course. So instead, I'm just going to give you a website that shows you some economic uses of minerals. These are things you can look up, and I might have you do that during the semester, but I'm not going to ask you to memorize any of this. So the website I have here is actually a commercial website that sells rock and mineral kits, but they have some really good pages that talk all about minerals. This web address right here will bring you to this page, and they start by telling you a little bit about how much the average person in the United States consumes in their lifetime. More than 1 million pounds of rocks, minerals, and metals. That's amazing. And they go through and they tell you exactly how that much material is used. For example, 800 pounds of lead per person is being used in construction of batteries, radiation shielding during x-rays, the dentist and the doctor, protective shield on TV screens. If you drop down a little farther on this page, you'll get to individual minerals and examples of what they're used for. I've circled the mineral names because this is kind of a dark slide. One of these here, galena, is the source of lead that was described over here, and so it tells you what it's used for. Other ones tell you what they're used for. Fluorite, what do we use fluorite for? Well, we use it in fluoride toothpaste, and we also use it to make hydrofluoric acid and a number of things. You'll find that many of the things in your life are created from mineral and also rock resources. This graph is from Lab 12, and I already went over it during the Lab 12 discussion. This is showing consumption rate versus GDP, or gross domestic product. And these are economic indicators that tell us something about the wealth of a country. The GDP is a gauge of the health of a country's economy, what's being spent by a country. And this is being shown in this graph by colors. The darker the color, the healthier the country's economy. The other axis on that graph was consumption rate. Consumption rate gives us an idea of goods and services that are consumed per household. And this is believed to drive a country's economic growth. The more consumption, the more growth. This map here is showing the consumption rate of salt. I couldn't find a consumption rate of metals to match the graph. But this is showing how any country that's in red has a very high consumption of salt. Blues and greens have very low consumptions, and yellows are sort of in the middle here. So when you take these two things together, as I described in the other video, countries that are located in the upper right part of this diagram include places where people have jobs and they're making enough money to spend a lot, to consume a lot. The lower left part of the graph is places where there's high unemployment or the wages are quite low and people don't have money to buy things. There's a low consumption rate. Here's a concept map that describes the flow of factors related to minerals and economic and societal factors. I've given you a copy of this on Canvas to download, and I want you to be able to use it in the way I'm going to in the next few examples. But first, let's look at all the different parts here because it is a pretty busy diagram. Everything in yellow is what we're going to really focus on. So I'm going to start over here at mineral resource. A mineral resource is a deposit in the ground that has a mineral that we want. If that mineral can be extracted from the ground at a cost that's less than what people would pay for it, then that becomes a mineral reserve. And things that affect that include the overall price that people pay for that mineral, which varies quite a bit on a bunch of other factors we'll get to. And then the mining cost, the processing cost, and that depends on all of these things in these darker boxes, which we're going to talk about near the end of the semester when we talk about mining. So if we have this reserve and if it's economically feasible to extract this mineral, then we mine it, and that increases our mineral supply of that particular mineral. The mineral supply can also be enhanced if we recycle or reuse that particular mineral in some way. And then we get to the main part of the diagram. So if we have a large amount of a mineral supply, when higher, you follow this arrow, when high, it lowers the price. So if we have a large abundance of a certain mineral, it lowers the overall price. If we have a scarcity of a particular mineral, then the price increases. Other things that can affect the price include consumer demand. If there's a high demand for a particular mineral, then the value of the price goes up. If there's a low demand, then the price goes down. If the price is too high, as it shows along this arrow, then people might seek out a substitute mineral or a substitute product, and that's going to lower consumer demand. Or if the price is low, it might increase consumer demand. Some other factors are down here. Consumer opinions and preferences about the mineral itself and about the technology and products that the mineral is being made to use. So if those opinions are positive, then they're going to increase consumer demand, which is then going to increase the price. If those opinions and preferences are negative, then they're going to probably seek out a substitute product and the consumer demand will go down. If a product is desirable, it's going to increase consumer demand. And so that's the way these various things on this graph work. So let's look at an example. I'm going to give you two examples, one related to the mineral supply changing and one not related to the mineral supply changing, and that's what this first one is. We're going to look at the element tellurium, which is found in metallic minerals that are called telluride minerals. And this is a graph, these are real data, they're not made up. This is a graph showing the price of tellurium from 2000 to about 2012. And what you can see is that tellurium had a pretty constant and low cost till about 2003, 2004, and then the price kind of skyrocketed, had a couple bumps, and then finally it fell low again. So what was going on? I'm going to use this concept map to illustrate. So it turned out that thin films of tellurium were very useful for solar cells. And so solar cells became very popular in the early part of the 21st century. And so the demand for tellurium increased. As a result, the price of tellurium increased. So if I show you this on this chart, we have a technology, a product that's desirable. And so it's increasing consumer demand. And when consumer demand is higher, the price goes up. However, there was also something else going on. Even before the use with solar cells, tellurium was used by metallurgists to make alloys. But when the price went up because of its demand for use in solar cells, metallurgists decided to find a replacement. And they found something else, and that decreased the demand for tellurium. So on our chart, the price was too high, they sought a substitute mineral, the demand went down, it lowered the price. And so that explains this price drop over here. So this initial increase was related to the new use, and the drop was related to its decrease in use. And also by this time, most solar cell companies had used the tellurium they needed, and the demand wasn't as high anymore. Here's a second example. This one is related to the mineral supply. This is showing the price of cobalt, which is a byproduct of copper mining. And cobalt is a strategic metal that's very important in industry. The primary place that was producing cobalt in this early time period, in the 1970s, was an African nation of Zaire. And in 1977, right where this spike occurred, there was a problem with the mineral supply. So what happened was the mining operations in Zaire were interrupted by uprisings of separatists in this time period. And so mining stopped. So the price skyrocketed because the supply was suddenly low. And this led to the development of a substitute. So if we look at this on the chart, we have our mineral supply, and it became low, so the price increased. And because that was too high of a price to pay, people looked for substitutes. And actually the substitute that was found was neodymium for magnets. So samarium and cobalt magnets were being used to make sound in speakers and phones and for electric motors. And then they were replaced with neodymium magnets, which are rare earth elements, which we're going to talk about in Lab 13. This decreased consumer demand as well as the price. And that's where we got the graph. Next up, igneous rocks and minerals.